Okay, so here's an example of an exponential function. It is 4 to the x, and you're asked a number of pieces of information, and then we have a second example below. So first of all, okay, most of these you can do without a table of values or without graphing. We said that all the y-intercepts, for now, are going to be 0, 1, and you can get a y-intercept by plugging in 0 for x, and if we plugged in 0, anything to the power of 0 is a 1. What about the x-intercept? Well, first of all, we wouldn't know how to solve if we put in 0 for y. We wouldn't know how to solve that other than knowing that you cannot get an exponent and make that equal to 0. So there is no x-intercept. But how would you know that? Well, you don't really know, other than the fact that if you looked at all the graphs that we have done, we have not seen an x-intercept on any of these yet. That will change when we get into shifting things up and down. All right, we're going to do that in the next section of this unit, but we're not right there right now. So you can see right here that all the graphs, all the exponential functions that we've done have had a horizontal asymptote at y is equal to 0. So that hasn't changed until we do translations. And therefore, if the horizontal asymptote is along the x-axis, then our graphs are never going to intersect, so we're never going to have an x-intercept. Okay, what about domain and range? Okay, well, first of all, the domains for these are all real numbers, so that doesn't change. And in fact, even when we do translations, that doesn't change. Okay, that's one of the features of exponential functions is all real numbers. And you can see from this graph in particular that it's going to go infinitely left, infinitely right, no PODs or anything like that. Okay, so we have a continuous graph. And then everything is also above the horizontal asymptote. So for that reason, okay, what we can do for all of our ranges is we can say it's from 0 to infinity. And I put a round bracket on the 0 because it doesn't actually touch. It's like one of these, y is greater than 0, not the greater or equal to. Okay, it doesn't actually equal 0. So we would just do a strictly greater than. And remember, when it's not greater than or equal to, if it's just greater than, then for the new range rotation, we use a round bracket. And we've answered everything except for, is this growth or decay? And remember what we said, if the number that's to the power of x, which in this case is a 4, if it's greater than 1, then it's a growth curve. It's increasing as you move from left to right. So it's growing. It's quadrupling every unit of x. So if you want to think about this in terms of a word problem, it could be like a population of bacteria is quadrupling every unit of time, which would be like maybe every day or every hour or something like that. In the second example, we have 1/3 to the power of x, and almost all of our answers will be the same. The only thing that changes when you have a number that's between 0 and 1 is that it now becomes a decay function. Okay, our x and y intercepts, our domain and range, our horizontal asymptotes are all the same, as we saw in the previous videos when we looked at some graphs.